Hello everyone, my name is Jasmine Clark and I'm an evangelist for the Developer Relations team. I'm excited to present this training series for the Carbon Black Cloud APIs, so let's get started. This series includes an introduction to REST APIs, calling Carbon Black Cloud APIs using curl requests and Postman, API error handling and troubleshooting, and using the Carbon Black Cloud SDK. This lesson is the fourth in the series and it introduces API error handling and troubleshooting. An important element of any software application is concise, useful error handling. Error handling refers to the anticipation, detection, and resolution of programming, application, and communications errors. Since errors cannot always be avoided, software should include code or software tools to handle errors in a way that makes it easy for users to understand what went wrong, how to fix it, and how to resume when interrupted. There are 7 categories of errors that can occur in software. A functionality error occurs when a user is trying to perform a task they expect to work, but the software makes it difficult, confusing, or impossible. An example of this type of error is a button displayed on a screen that is not clickable. A communication error occurs when the software does not provide all necessary information to the end user. Some examples include the absence of a help menu or instructions, or a save button that deletes a file instead of saving it. The user is expecting the button to do as labeled and save the file, so there is a miscommunication between the expected behavior and the actual behavior. A missing command error occurs when an expected command is missing. For example, a user completes a form, but there is no way to submit or save it. Another example would be a pop-up with no close or cancel button, so the user is unable to navigate back to the main screen. A syntactic error occurs when misspelled words or grammatical errors are displayed to the user. These can be confusing to users and also make the software look unprofessional. An error handling error is when an error occurs while a user is interacting with the software and is not handled in a clear, meaningful way. A common example of this is when an error message simply reads error instead of providing the user with useful information. A calculation error is caused by bad logic, incorrect formulae, mismatched data types, or coding errors. For example, the user inputs a value in inches, but the code performs the calculations in centimeters, giving the user the incorrect result. Lastly, a control flow error occurs based on what the software is expected to do next and in what condition. An example of this type of error is a user clicking a button labeled Save and Close after completing a form, and the form saves but does not close. Part of the expected behavior was performed, but the next step in the process was missed. Most of these errors are related to code, but some can exist in documentation as well. Our goal at Developer Relations is to equip users with all they need to successfully use our APIs, and bugs in the documentation are just as important as bugs in the code. Please let us know if you come across any, as we are happy to have EAs for documentation improvements. Now that we've talked about the categories of errors, let's move on to specific error codes users may see when calling our APIs. A 400 error occurs when someone has created a bad request. This can happen if required fields are missing, header values are not filled in properly, the wrong verb is used and another call uses that verb, the API version is not up to date, required query parameters are missing, or the user sends an empty request. The solution for correcting this error type is to compare the fields, header values, verb, API version, query parameters, and request requirements with those in the API documentation on the developer network. The example shown here is caused by an incorrect verb in the API call. As you can see on the left, this call requires a post method. If the user selects a get method instead, the server will return a 400 bad request error. A 401 error indicates that authentication has failed, meaning that the API does not recognize the user. This could be due to a missing or invalid API key, an expired token or session, or an incorrect hostname. Potential solutions for correcting this error type include verifying the correct key type, verifying the API key is set and correct if using Postman or the SDK, verifying the token is not expired if using OAuth, and verifying the hostname by comparing it with the authentication page on the developer network or the CBC URL. The example shown here is caused by a missing token. Without the token, the user cannot be authenticated, and the server will return a 401 unauthorized error. A 403 error indicates that authorization has failed, typically due to inadequate permissions. This differs from the previous authentication error because in this case, the API recognizes the user but knows they don't have access. Potential solutions for this error type include verifying the access level and key type by comparing with the API documentation on the developer network, and verifying the host name by comparing with the authentication page on the developer network or comparing with the CBC URL. The example shown here is caused by inadequate permissions. The API recognizes the key, but the user doesn't have permission to make this specific call. A 404 error occurs when the server cannot find the requested resource. This can be caused by an incorrect org key, incorrect permissions, an invalid API route, or calling a route that requires an ID without the ID or with one that doesn't exist. Potential solutions for this error type include verifying the org key in the URL matches the org key in CBC, verifying the access level, key type, and API route are correct by comparing to the API documentation on the developer network, and verifying the ID is present and valid for applicable routes. The example shown here is caused by an invalid route. Per the API documentation, the route should end with _search instead of just search. A 405 error occurs when the server knows the request method, but the target resource doesn't support the method. This can be caused when the wrong verb is used and there's no other call that uses that verb, or when the API route is incorrect or the hostname is incorrect. Potential solutions for this error type include verifying the correct verb and route by comparing with the API documentation on the developer network, and verifying the correct hostname by comparing with the authentication page on the developer network or the CBC URL. The example shown here is caused by incorrect verb usage. The alert search API requires a post method, but the put method has been selected. A 410 error occurs when the resource requested by the client has been permanently deleted. Users may see this error when trying to call a deactivated API. Potential solutions for this error type include verifying the latest version of the API is being used by comparing with API documentation on the developer network, and checking for recent deactivation notices on UEX or the developer network. The example shown here is caused by attempting to call a deactivated API. A 415 error occurs when the server refuses to accept the request because the payload format is unsupported. This can be due to a missing or incorrectly formatted request body, an incorrect content type header, or sending a string in the request when JSON is required. The solution for this error type is to verify the correct format, headers, and fields for request by comparing with the API documentation on the developer network. The example shown here is caused by a missing request body. This particular route does not have any required fields, but we still must send empty curly braces. A 500 error occurs when something goes wrong on the server. Ideally, we shouldn't see many of these when calling the CBC APIs, but occasionally they can occur when a back-end service fails to process a request correctly. In some of the API routes, they can also occur if the user sends the wrong file type, i.e. sending a text file when a JSON file is required. Potential solutions for this error type include checking if a maintenance window or incident is active, escalating the issue, trying again later, and verifying the correct file type is used for applicable routes. The example shown here is caused by an incorrect file type. Lastly, I've included a quick reference guide with information about each of the error codes we discussed today for you to refer to as needed. Whether an error is caused by the user, the code, or the server, it's important to be able to provide clear, concise information to users to help them understand what's preventing them from completing their desired actions. We can use these error codes to offer suggestions to help them quickly get back on track. Now that we have some general knowledge about error handling and we know how to troubleshoot errors specific to the Carbon Black Cloud APIs, we can use this knowledge to more effectively use APIs. Coming soon is our final lesson in the series where we will learn how to harness the power of the Carbon Black Cloud SDK. Thank you for your time today, and I hope this information has been beneficial. I look forward to seeing you in the next video.